The manufacturing sequence for the new ceramic can be summarized in the following steps. First, the preparation of the starting material. Second, the shaping. Third, the sintering. And finally, the finishing. While the sequence is nearly the same as for the traditional ceramics, the details are often quite different. The strength requirements are usually much greater for the new ceramics than for the traditional ceramics. The starting powder must be smaller and more uniform in size and compositions, since the strength of the resulting ceramics products is inversely related to the grain size. A greater control over the starting powder is required. Thus, the powder preparation includes a mechanical and chemical methods. The material properties for the new ceramics include the low density, the high hardness, the excellent wear resistance, the good wear resistance, the good heat conductivity, and the instant freezing and heating. Many of the shaping processes are borrowed from the powder metrology and traditional ceramics. The powder metrology, press, and sinter methods have been adopted to the new ceramic materials, and some of the traditional ceramic forming techniques are also used to shape the new ceramics like the strip casting, the extrusion, and the dry pressing. The hot pressing is similar to the dry pressing, except it is carried out at elevated temperatures, so the sintering of the products is going to be accomplished at the same time with the pressing, and this will eliminate the needs for the separate firing step. Higher densities and finer grain sizes are obtained, but the die life is reduced by the hot abrasive particles against the die surfaces. The isoscenic pressing is used a hydrostatic pressure to compact the ceramic powders from all directions, and this will avoid the problems of the non-uniform densities in the final products that's often observed in the conventional uniaxial pressing. The same process used in the powder metrology. In the powder injection molding, ceramic particles are mixed with the thermoplastics, then heated and injected into a mold cavity. The polymers act as a carrier and provides a flow characteristics for the molding. Upon the cooling, which hardens the polymers, the mold is opened and the part is removed. The plastic binders is removed and the remaining ceramics parts is sintered. Because the plasticity needed to shape the new ceramic is not normally based on water, the drying steps required for the traditional green ceramics is omitted for most of the new ceramic products. Sintering step is still a very much required. The functions of the sinterings are the same as before. First, is bond the individual grains into a solid mass. Second, it will increase the density. And third, it reduce or eliminate the porosity. Parts made of new ceramics sometimes require finishing with one or more of the following purposes. First, to increase the dimensional accuracy. Second, to improve the surface finishing. And third, to make minor changes in the part geometry. The finishing usually involves an abrasive process. Diamond abrasives must be used to cut the hardened ceramic materials.